All right, let's do this. So homework 2 is posted. I don't want to talk. I won't talk too much about homework 2. We're actually just in case there's still a question about this now that we're in the semester, but the course is broken into 4 3-week sections, and each one correlates to a homework. So today we're starting the homework 2 content. I'm done talking about homework 1. I've said everything I need to say. If you all got questions, I'll be happy to answer them as long as there's time in lecture. But I'm done with homework 1 content. Moving on to homework 2. So this is homework 2 content for 3 weeks, and not after spring break. And then 3 weeks of homework 3, you get the idea. But today is the start of homework 2 content. So homework 2 is released. The one big thing I want to say about homework 2 right now is this is significantly more difficult than homework 1. Please start early, yada yada. You've heard it all before. You'll either ignore me or not. But this is a huge jump up in difficulty from homework 1. Homework 1 really is the let's ease into 3.12, let's get used to what TCP sockets are, Docker Compose. Like all that stuff takes a while, just getting your bearings and figuring out what the hell's going on in this course. Realizing that I want you to parse HTTP requests manually, you're starting from bytes, like just all that stuff. There's a lot of little stuff there. So in terms of the actual code I have you write, it's not all that much. If you do all the application objectives, it's a good chunk of code, but especially if you're just doing the learning objectives or maybe the learning objectives and application objective 1, it's not all that much. It's basic HTTP header parsing, not even header, just the request line, and then responding with the right thing. Not too much going on. Homework 2 is going to jump that up by a lot. It's a lot. Just historically, this is the one where students hit the wall in is that the right expression? Where they kind of hit a brick wall and progress slows. In my opinion, homework 1, super easy. Hopefully you all feel that way. It, again, takes a bit to just get set up with everything, but the easiest homework of the course so far. Then the difficulty spikes up for homework 2. I think it's roughly about the same for homework 3. Maybe it tapers off a little bit. I think homework 2 and homework 3 are about the same difficulty, but by the time you get to homework 3, you're a much better programmer, much better web developer specifically. You're much more comfortable with HTTP and all these protocols and stuff that we're using. So I think it feels a little bit easier. And then for homework 4, it drops down by quite a bit. Homework 4 is not as easy as homework 1, but much easier than homework 2 and homework 3. So if you're planning your semester and trying to figure out how to allocate your time or anything, that's my take on the difficulty of the 4 homework assignments. So if homework 2 is completely destroying you and you're really struggling with it, don't fall into the mindset that, holy shit, homework 3 is going to be much harder than this, and homework 4 is much harder than this. If you can handle homework 2, you can handle this course. So don't get overwhelmed while you're doing homework 2 and feeling like you're not making it through. If you make it through homework 2, you got what it takes to make it through this course. You just got to stay with it and keep doing it. But I added this warning because too many students were trying to start. A lot of students would start homework 1 at the last minute and then think they could start homework 2 at the last minute. So I added my big red warning here in this speech and lecture, just to make sure you at least hear me say that this is much more difficult than homework 1. Overall, depending on who you ask, I don't know if it's objectively difficult. Like there are tougher 300 level CSE courses for sure, especially if you're taking 400 level CSE courses. There are much tougher things out there. Objectively difficult, I'm not so sure. Much more difficult than homework 1 though. I can't say that for sure. All right. Any questions on anything? These aren't, I just realized I'm playing with these. Anybody leave their charger for AirPods? It's empty, but it's the charger for it. It's still important. All right, no questions? Talk about front-end development. This is the one front-end lecture. which may be a little debatable. I have like a little bit of content somewhere else too. But front-end development in one lecture. This is not a front-end development course. This is all about back-end protocols, things like that, servers. But you need to know what front-end development is. So I assume most of you are somewhat familiar with what is going to be covered today. It's going to go at a very quick pace because of that assumption. But let's talk about front-end development for one lecture. We're going to talk about HTML, CSS, and JavaScript. It's our core trifecta for front-end development. HTML, hypertext markup language. Yeah, to make sure these are my updated slides. I just downloaded them. I know they're my updated slides. But I thought I fixed this one. The indentation, the lack of margins bugs me on this one. I thought I fixed this one. Hypertext markup language, it's a language that marks hypertext. Hypertext means any text that can link to other text. The idea that you have links on web pages is fundamentally core to the, not the internet, to the World Wide Web, I guess. Do we still use that term? To the web. And that's part of HTML. HTML, very fundamental to it. It's right in the name, the fact that you can link to other documents from your documents. Other than that, it's a markup language, which means it's there to just give structure and context to the things that you're typing. It's just marking up your code to make it, I guess I already said it, but more structured. HTML is not a programming language. Don't let anyone tell you that. If you have a resume and under programming languages you list HTML, please update your resume and change that. It might sound silly, but like I've reviewed resumes where I've seen that, and it's not an outright throw it in the garbage pile, but it sways my opinion, and it should sway anyone's opinion a little bit, especially if it's a web developer position. Like if you're calling HTML a programming language and you're a web developer, don't apply for my position. So here's HTML. This is just a sample basic HTML page. As I go through this lecture, I'm not going to focus on all the little details and everything. I just want to get enough context out there so when I do need front-end discussion later in the semester, I can draw on what I showed you today. So I'm not going to go through, here's a table, here's how you do rows, here's how you do unordered lists, here's how you do ordered lists. I'm not doing that. I'm just going to talk about like what HTML is at a very high level, at a structural level. So HTML consists of elements which are defined by their open and close tag. So I have an H1 element, or an element of type H1. It starts with the open tag and ends with the close tag. Everything in between the tags is the content of that element. H1 is a header, so my first page, as we saw, is going to be rendered as large text. A lot of elements exist. Again, I'm not going to go through all of them because that'd be tedious. You can go anywhere else for that. But they can be nested. So I can have elements within elements. Within elements, I have a body element containing 3 other elements. And the structure of all these elements and all the nesting creates the DOM, the document object model, which is a big data structure containing all the stuff in your web page. Starts with the HTML, has a head and body, and then the body has all the stuff that your user can see, and the head has all the stuff that your user can't see. Oops, got ahead of myself there. So the head, all the stuff that doesn't appear on the page. The title is going to be what appears in the tab at the top of the browser. Whatever you have here is the title. It's going to show up there. Body is everything that's rendered to the screen to the user. There are also self-closing tags, so not all elements are defined by an open tag and a close tag. Some of them are self-closing. So if you see a tag that has this trailing slash and there's no open start image, end image, there's no start new line, end new line, there's no start horizontal rule, end horizontal rule. It's just the one tag with a slash. That's self-closing. It's both an open and closing tag all rolled into one. So images are like this. If I have an image, I just want the image there and maybe some extra attributes. But I don't need a start tag and a close tag because there's not going to be any content in that image element. It's just there for the image itself. And speaking of attributes, elements can have attributes. These are key value pairs. So name and value of the attribute. This div has an attribute named ID with the value myDiv. On the previous page, we had an image with an attribute named source with the value slides.png, meaning this image let me get my ordering here, my phrasing. This image element requires an image named slides.png, and the browser, when it reads that, it's going to see that it needs more content, and it's going to make another request to your server for slides.png as the path. It's going to send a GET request at the path slides.png to get that value, to get that image, the bytes of the actual image itself. And we can see these attributes all over here. Comments, for what it's worth, HTML only supports block comments, no line comments in HTML. That's all I got to say about that. I've seen BR without the slash, and it consistently breaks automatic parsing the HTML file as XML. Well, HTML is not XML. Don't use XML parsers for HTML first. You can leave out the slash for a BR, for a line break, but you're wrong. Like you can do it, but you're wrong. The reason you get away with that is browsers are really robust. Browsers will do whatever they can to render your code, even if it is riddled with errors, and syntax errors and mistakes like that. The browser will be a bro. It'll be like, I think I know what you mean, and it'll guess what you mean. And in the case of just BR, it's going to be like, yeah, I think you meant BR slash. And it's not going to hold that against you. But if you're parsing it, if you're putting it to any program that's not a browser, that's not doing everything it can in its power to render your page and deliver a user experience to the user that you intended, yeah, it's going to break. So a parser is going to break when you have invalid HTML, but the browser is going to be fine with it in a lot of cases. Browsers are really, really powerful pieces of software. They do a lot for us, sometimes for the worse. I kind of wish it would just say, hey, you got some mistakes here. You got to run your HTML through a validator and have that find your errors like that for you. Should I say that? I haven't ran my pages through a validator in a while, so I might have errors in my HTML even. Try it on CSE 3.12. It might be broken. If we want special characters, we can do Unicode characters in our code using this syntax. Ampersand, hashtag, is that what we call it now? We used to call it pound symbol and number sign way back when. I guess hashtag now that Twitter's a thing. The hex value of the character you want, and then a semicolon. So this is our way of escaping Unicode values in our code. Whatever Unicode value it is, that's what's going to render on the page. So in our HTML, it's this, but when it's rendered for the user, we're going to see the rook symbol there. If we want extra white space, if you want a lot of extra white space, do something better than this. If you want a little bit of extra white space, extra white space will be ignored in HTML. So if you have web and then 100 spaces and then page, when it's rendered to the user, all those spaces get collapsed into one space, and it's just web space page. If you want like one extra space, non-breaking space is a way to do that. There are Unicode characters with special named constants, NBSP for non-breaking space, so we don't have to remember the Unicode hex encoding for a space. It's one of the shortcuts that we have. So non-breaking space, this will be space, space, space. We'll actually get 3 spaces here in between the rook and web page. So if you do want just a little bit of extra space, non-breaking space. If you want a lot of extra space, use CSS or some other solution and get some actual horizontal spacing element in there. Get something else. But if you just need a couple extra spaces, non-breaking space is nice. And that's it. That's HTML. Everyone knows HTML now. You probably did already before you came in here. But if you didn't, you do now. There are lots of things. Again, I'm not going to go through, here's ordered lists, here's unordered lists, here's how you nest your divs, oh, that's a bad example. Here's how to make links. But W3 Schools is still a great resource. It was a great resource when I was first learning web development. I think it's still a great resource. It explains things in a nice, simple way. Don't let anyone tell you W3 Schools isn't the best. It's awesome. Go out there and use it. If you don't like W3 Schools, you want a different resource, just go out there and find, there's millions of resources, probably literally millions of resources out there that can help you. Anything that we need for the class, I'll cover. We're going to start using HTML forms. So on Wednesday, I'm going to say, okay, you know HTML now. Now let's talk about HTML forms and how they use attributes and stuff. So anything that we actually need for the course, I'll cover. But you're encouraged to go out there and just explore what's out there. There's a lot of fun stuff that you can do with just going through a few tutorials and building some cool stuff. Just not what this course is about. CSS, I need you to know elements and attributes. Really, that's what I need you to know from today's lecture. So HTML is fine. HTML is going to define the structure of your document. CSS is going to define the style. Cascading style sheet is going to define the style of your website. And it's good practice. You've heard this. You probably heard this right from 199. You may not have heard it again after that, actually, but you've at least heard it in 199 probably if you took it while Alan was doing his web modules. That you should store your CSS in an external file. You have your .html file, you have your .css file, and of course you did this on homework 1, or some of you are still doing this on homework 1, where we have separate files for these things. It's generally good practice to keep these separated. We want to keep the structure of our websites, which is the HTML, separate from our styling, which is the CSS, and separate from the functionality, which will eventually be our JavaScript when we get to that part. And we'll take that a step further, not today, but we'll in how many lectures? I don't know, later. We'll take this a step further in separating the structure of the HTML from the actual data that we're going to inject into the HTML. So we want to keep things as modular as possible. This is generally a good idea in all of programming in general, all of software engineering. And this is one case where we want to do it. We keep the structure separate from eventually our data, separate from how we style that structure, and how we actually add functionality to that structure with our JavaScript. Keep all those separate. Don't intermingle them. When there's nothing worse than, well, there are worse things, but it really sucks to see an HTML file with all of the styling and JavaScript all in line with all the data hard-coded into it. It's an absolute mess, an atrocious mess to maintain. That's one of those projects where the client says, can we get this new feature? And you just say, no, we can't do it. The code is completely rigid. We cannot do anything with it. I say styled? How content is styled? I guess. In this course, again, we're focused on back-end functionality and how things work and protocols and all that stuff. You're never going to be graded on the quality of how your stuff looks on the front end. Where this comes up mostly is the project. If your project looks like crap, but it works, you're good in my book. You're encouraged to make it look better, but only after the functionality. Build the functionality first, get it working, get your grade, and then if you want to make it look good after that. It is really nice to see a project where the team clearly took pride in it and made it look really good, but you're not going to be graded on that aspect. On the other side of that coin, if your app looks amazing, but it doesn't work, I don't care that it looked amazing. I'm not grading you on that. I'm not going to be graded on that. So you're not graded on any aesthetics. It's not an art class, this is a science class. So yeah, you're just not graded on that. But we do want to know what CSS is. And if you don't believe me on that, just look at the sample page that I gave you for homework 1. It looks like crap. Even what I gave you doesn't look good. I can't grade you on how your sites look and then give you that as a sample page. I just couldn't do that. All right, so here's some CSS. What this CSS would do is I guess it's pretty self-commenting. Change the background color to aqua and the paragraph color to red. Well, that one's not self-commenting. And the font size to 50 pixels. This is an RGB value, so 2 hex values for red, 2 hex values for green, and 2 hex values for blue. So FF, that's the max value, 255 for red. Did I say the right color? Red, 0 for green, 0 for blue. This is going to give me plain old red. But you can mix and match your hex values to get whatever colors you want in there. I spent way more time than I'd like to admit on different pages, especially like the course web pages, trying to get the exact right color down to the exact hex value of these. You can spend a lot of time picking the right colors. I'm not an artist, so I have no idea what I'm doing. I just guess and check 100 times. And they probably still don't look great. I did not do that for this. This just looks, those are bad colors. All right, so when we have our CSS, we have this saved in a separate file. I saved this in a file called style.css. And then we have to import it into our HTML. But it's very different functionality of import as, importing in a Scala program, for example. We're going to add this self-closing HTML element in the head of our document. And it's going to have a link to the style sheet for this page. So we tell it with this syntax. We link to the style sheet that's going to be CSS. This is the MIME type and the file, the path of where it's hosted. So your browser's going to read this, parse the HTML, get to this line, and say, whoa, I need something called style.css. It's going to make an HTTP GET request to your server for style.css. I keep saying this because I get questions. We're still getting questions in office hours of students trying to get one request for the homepage and respond with HTML, CSS, and JavaScript all in one response. It's going to be multiple requests, multiple responses. You respond with just the HTML. The browser parses your HTML. It says, whoa, we need style sheet. Sends another request. You return with just a response with just the CSS. And then eventually there will be a JavaScript here. It's going to say, whoa, I need JavaScript. Request the JavaScript. You respond with the JavaScript. Only respond with what's being requested, nothing more. It's the way web browsers work, or web servers work. So we import it. We get another request. We get the CSS. And then the browser is going to take the CSS, take the HTML, smash them together, and then render the page via magic. So if I have that HTML, if I have this HTML, I'm going to change this content to red and big. I'm going to change the background of the body to aqua. And my first web page, I didn't do anything with that. So I got the style applied to my HTML. But what if we want more flexibility than that? I got 2 different paragraphs. I want one to be red, one to be green, but I just said all my paragraphs are red, and they're all going to be big. How do I change this? Classes, CSS classes. We're going to add an attribute to our HTML elements that's going to specify the CSS class for that element. So I'm going to say this paragraph is of class red, and then in my CSS, I'm going to say all paragraphs are going to be big. So I want big font on both of them. In this example, you can do whatever you want. But any paragraph with the class red, make it red. Any paragraph with the class green, make it green. So we can divide these into finer categories, and it's generally good to use classes. It's a little too powerful to set some styling for every paragraph. Usually we're going to use classes to narrow things down and have a little more control of what we're doing. And that's not good enough for me. What if we want things to be... I knew it. I knew I had a slide like this. I was looking for it when I was reviewing these this morning, and I still missed it. We have 2 classes. We want these both to be red. It still works as the example, but it could be better. We have this paragraph and this div. I want them both to be red. But in my style sheet, I said, okay, any paragraph with the class red is going to be red. That's not going to apply to this div. Unless I do. No, I didn't. That's not going to apply to this div. Even though it's of class red, I said only paragraphs, that's how this is read, only paragraphs with the class red should have this styling applied to it. If we want styling to apply to all elements, regardless of type, we just do dot. We leave off the type of the element and just do dot green. This would mean every element with the class green is going to have a font color of green. I don't like my example. This div should have been green to emphasize, or a second div with green to show you that the div would be green. If this div was class green, this font would be green. The font for the div is small because I only made paragraphs big font size. So these all get mixed and matched based on the type, based on the classes, just based on what applies to which element. This does not apply to the div, so we got small font. This does not apply to the div because it's only for paragraphs. Green applies to the paragraph, even though we didn't specify. We just said dot green. That means anything with a class green it applies to. So it applies to this paragraph because it has class green, regardless of the type. A div with class green, it's going to have green font. This div with class red doesn't have red font. So we can mix and match and have a lot of control and flexibility over what elements we're going to style with which styling. And if we want styling to apply to one single element, the last piece of syntax that we can use in CSS, we use a hashtag and then the ID of that element. So with our div, and we saw this right from the first HTML, we have this div with an ID of my div. IDs have to be unique. If I have this with ID my div, I can't have any other element in my entire document, in my entire HTML, with an ID of my div. They have to be unique across the entire page. And then I can style it with my CSS with hashtag my div. This styling only applies to whatever element has the ID my div, so only applies to this element. It's generally not used that much, but it exists. It's syntax you can use in CSS. The IDs being unique, that's another one of the things like mentioned with the breaks without the self-closing slash. If you have two elements with the same ID, the browser's going to be like, yeah, I know what you mean. But it might break some of your JavaScript that's interacting with your code, with your HTML. It's common to get an element by ID in your JavaScript. If you have two elements with the same ID, you got a bug. But your page will still render. So it's strong to say you can't, but you really shouldn't. When it comes to front-end web development, there's very few things that you actually can't do. The browser, it'll render whatever you give it in some way. You just might not get what you want. And if you're not, I'll talk a little bit about that. If you are relying on that, you'll just kind of write HTML, CSS, and JavaScript, and and tweak it until it works in your browser. But you have just complete crap code. All your syntax is all off. You don't have your slashes on your breaks. You have multiple elements with the same ID, and just syntax errors all around. But you fiddle with it until it works in your browser, especially when it comes to CSS. And you put exclamation important on everything. And eventually it looks good. What's going to happen is your users are going to open it up in a browser that isn't the exact version of the exact browser you tested with, and it's not going to render right at all. That's how you get browser incompatibility issues, is your one browser helped you out and rendered it the way you expected. But another browser, when it guesses and says, well, I think you meant this, it's going to have a different guess, and your website's going to show up different in every browser. It's going to be broken in some browsers, works in some browsers. And this is frustratingly common even with professional sites that are out there. Check in I forget what page it is, but one of the pages on NFL.com when I'm checking scores and standings and stuff doesn't even render in Opera, but renders. I always have to jump over to Chrome, and it renders fine in Chrome. Like a lot of sites out there have browser compatibility issues. Don't write code like that. Can we get better stuff out there, please? Go do better than the current crop of devs that are building stuff. Verizon Fios' webpage, y'all probably haven't had a reason to mess with that website yet, but oh my goodness, Verizon Fios' website breaks every single time I'm there. It never does what it's supposed to do, and I don't know. I should know the answer to this, but I don't, embarrassingly. If there's a use strict equivalent in HTML, I want to say there is, but I feel like I would have encountered it a lot if there was. There's use strict in JavaScript. I feel like there is, but I forget off the top of my head what it is. I think there's a tag you can put right at the top of your HTML document that says be more strict about this. Why do I use Opera? Why not, I guess. I'll use a browser. Like a browser will be my main browser for a while until it pisses me off, and then I'll switch. So Firefox pissed me off, then Chrome pissed me off, and I'm like, well, what else is out there? So I did some research, and Opera seems to be the third best choice. So I've been using Opera for a while, and it hasn't pissed me off. So the only bad thing about Opera is what I just mentioned, is I do get incompatibility issues because devs apparently don't test on Opera, which is weird because it runs on Chromium. It's basically Chrome with a different coat of paint. So it's weird that there are compatibility issues. But I don't have a good reason to use it. It's just the browser I'm currently on. I'm on the verge of switching back to Firefox, actually, so I might stop using Opera. I don't know, maybe not anytime soon. Is there a way to test browser compatibility besides manually? There is. I don't remember the site, but there's a website you can go. You can punch in your URL if you have a deployed site, and it'll check all your syntax for you. That's what I was mentioning. I haven't ran that in a while on cc312.com, so if you do, send me the results, and I can see how bad it is. But there are validators out there. Let's go on a little adventure. Right? HTML validator. Markup validation service. Let's see. This will be embarrassing if I have a lot of mistakes. I probably do. I haven't checked in a while. But this will give you all of your errors. Verifying you are human. Why am I seeing this page? I'm human. I just promise I'm human. It's saying to not use trailing slashes? No. Which element must have... Oh, I don't have my alt attributes. But yeah, you can run these to... Oh yeah, that's a lot. I assume most of it's just the same thing that I do multiple times. But yeah, it doesn't like my trailing slash. Did that change? I might be teaching the wrong stuff. I have to update my things. My tables, you know what, I did see this, and I should have fixed it when I saw that. Yeah, but there's all my stuff I got to fix. There's my to-do list on my website. I got to look into that trailing slash thing, though. I thought that was, like, the way. The validator, at least, is saying don't do that. I'll have to update that. All right, and that's, oh yeah, multiple classes. That's almost CSS. Yeah, Selenium's nice for automated testing for sure. Multiple classes, multiple classes, space separated. So I want this div to be green and wide. I want both of these to apply. Green, space, wide. You have as many classes as you want. It's common to have elements with 5 or more classes, separated by spaces. Class names can't have spaces in them, an implication of that. And that's CSS. As always, you'll hear me say this 3 times this lecture. Head over to W3 Schools if you want more, or just good old-fashioned Google, hey, what cool things can I do with CSS? You'll get all kinds of stuff. But that's all I'm covering of CSS. HTML elements can have classes, and those classes, in your style sheet, use those classes to actually style your stuff. Much better practice than just saying all paragraphs should have this styling. Separate it by classes, and then you can reuse elements. And it's pretty common, actually, to just use divs. Divs are like the lack of content. Like it's a nothing thing, I guess. Like paragraph is clearly, this is going to be a paragraph of text. A div is like, here's a division in my website. It's just a chunk of my website. And then you can add classes to those divs to style them differently, to have whatever look and feel you're looking for in your page. JavaScript. So again, I'm not really going to cover JavaScript in detail. Whenever you need JavaScript, expect you to find documentation, find the syntax. I'm going to hit you with the go to W3 Schools again at the end of this, but again, any tutorial is fine. If you come to, and that's in lecture, I should mention that for all these. That's in lecture. If you come to office hours, I'll answer any questions you have. I'll help you out with whatever you want. But in lecture, I'm not going to have a lecture where I say, here's how you do a loop in JavaScript. Here's conditional. We're beyond that. We're in a 300 level CSE course. We're beyond that. Whereas in 116, I have to do that at the beginning. Here's Java, here's loops in Java, here's data structures in Java. I don't have to do that in this course, right? I'm not gonna, so even if I should. It's 300 level CSE course. I can't do that. But anyway, this is where, I do have it on this slide. I'm going to recommend right away, W3 Schools. But this is where we're going to add functionality to our sites. This is where our sites get more dynamic. So with HTML and CSS, you can build what I like to refer to as poster sites. This is great if you're building like a website for a mom and pop restaurant and you just want to get your address out there, maybe post the menu, a phone number to call for more information maybe, and location. Did I say address already? How do you get to this restaurant? And that's all you want. And they don't have anything. I say mom and pop because something like they don't have online ordering and things like that. You can't order food to go or any of that. It's just information. Here's where you can find us. Come here and spend your money here. A poster site. It's just like pinning a poster on a bulletin board. You post your website on the internet, and it's just that. It's a poster. To make it interactive, to actually turn it into a web app and not a web page, we want JavaScript. And that's going to add the interaction that we're looking for. That interaction with JavaScript is going to make our sites dynamic and actually make them do things. That's all JavaScript. CSS and HTML can't do that. JavaScript, and specifically for this course, we're going to write JavaScript that talks to our server after the page loads and gets dynamic content that way. So that's what we're after. I guess technically with forms, you wouldn't need JavaScript, but it's not that exciting. HTML and CSS are not programming languages. Well, technically. I got called out on this in a lecture, so I have to mention it every time now. The combination of HTML and CSS is technically Turing complete, but don't use it as a programming language. Like, it's not practical, but technically it is the combination, not either of them on their own, but the combination of them. But JavaScript is just, it's a programming language. It's made to be a programming language. It has your loops, your data structures, your variables. It has all the stuff that you would expect. All the knowledge that you have about programming, you can do it in JavaScript with a few exceptions that we'll talk about in the next slide. So when users visit your website, or web app at this point, they punch in your URL, the browser requests all the things that it needs, including the JavaScript, and when the JavaScript is downloaded, the JavaScript runs on your user's computer. They're literally downloading your code and running it on their machine. Whenever you go to a website, you're downloading somebody's code and running it on your machine. There are security concerns with that. Huge security concerns. You should be concerned about that. You're running some stranger's code, especially if you're going to shady websites, and downloading it and running it on your computer. So there's certain things Because of that, because we don't all want to be constantly attacked all the time, there are certain restrictions that you can't do in JavaScript, specifically your front-end JavaScript. When your JavaScript runs in a browser, few restrictions that it can't do. One, can't read and write files. Thank goodness. I don't want some random coder whose site I clicked on by accident to be able to read all the files on my hard drive. Where this gets borderline frustrating, you cannot, in your JavaScript, read your files. So you have a server, you're serving HTML, you're serving the JavaScript, and maybe you serve 2 JavaScript files. And in one JavaScript file, you want to import something from the other one. You can't do it because you can't read files. You can't do that. If you want to serve a file that's a JSON object, you can kind of get around that. I'll explain. But if you want to serve a JSON file with just data and read that file, like I know the user had to download that file, it's got to be sitting right there on their hard drive. I just want to read that file that I gave them. You can't do it because you can't read files. You can kind of get around the JavaScript one because once one JavaScript file runs, any functions that it defines, they're going to be loaded into memory, and you can call those functions. So you just don't have to import, but you can't like import things. But they should already be loaded in memory, so it's not that big of a deal. But any data files, can't read them. Even if your server served them, can't read them. Just can't do it. So keep that in mind. Whenever you want to do that, like, oh, I served this JSON file, I want to read it in my JavaScript. Can't do it. Not allowed. And thank goodness, for security reasons, but just doesn't have file I/O functionality. If you took, you should have all taken 115. If you took 115 here, notice how when we got to file I/O, you did file I/O in Python, but you didn't touch file I/O in JavaScript. It says you can't do it. Without running Node and using Node to have backend JavaScript, can't do it. You can't do it in the browser. Can't access other tabs or windows. That should go without saying, I would hope. And you can't directly access any information from other sites. You can fire off HTTP requests to their servers and potentially access data, and we have to always be careful of that, making sure we're not leaking data in that way. But you can't just directly go into the user's browser and just root around all the information for other websites. Can't do that. Read cookies from other websites. Can't do it. Vulnerabilities are always exposed and patched. JavaScript seems to be doing pretty well these days in terms of security in the browser. Browser's got that on lock these days. But there will always be other vulnerabilities, and they'll get patched. So here's a very simple JavaScript script. If you have this as your JavaScript on your HTML, it's going to find a div with ID myDiv and set its content to this. We're going to save this in a file called script.js. We're going to link it to our HTML. Yeah, you can't access functions loaded in memory from another tab either. So your tab is its own separate environment. You can't access functions from another tab. Again, thank goodness. Besides the security issues, what if somebody in another tab names a function the same thing you named your function, and you accidentally call theirs? It would break a lot of things. We basically have a global namespace. So we import by linking it in a script tag. We do script. Now you could, in theory, put your JavaScript right in the script tag. Don't do that. We don't do that. It's generally bad practice. We want nice encapsulation, separation concerns, all those cool words that we hear about. This JavaScript is in its own thing, and it's kept separate from the structure of the code, which is the HTML, and the style of the code, which is the CSS. So if we just do source and then script.js, the browser is going to fire off another request for a file call, for a path, not even a file, but a path of /script.js. And your server should get that HTTP request and then respond with the code for script.js. And then once our page is loaded, that content will be added from JavaScript. If you've gotten to application objective 1 on homework 1, you've seen this in action. You have your hosting your JS, your CSS, your HTML, and you go to the HTML, and you should immediately see the content that was added from JavaScript, which is verification that that file was executed on that browser on that page. Again, W3 Schools, but JavaScript is an event-based language, which is really powerful. We're not going to, actually we will do a decent amount of event-based stuff in this class. But JavaScript is event-based, meaning we can set triggers that react to events that typically the user or our server is taking. So in this case, if I have this div, I just have a div. It's going to have some content. It's my div. It'll have this content added by JavaScript. And I want to make it a little more dynamic. Well, I can react to the mouse enter event using an HTML attribute. And when you set these on events, these listeners for these events, in your attributes, you can write any valid JavaScript code here. Typically good practice to just call a function that's defined in your JavaScript file. So you're getting away from HTML right away. We don't want a bunch of JavaScript code in our HTML. So I'm going to call a function makeBlue. With this is going to be, in this context, a reference to the element. So a reference to this div that just had a mouse enter it. And then I'm going to set a property. I'm going to set some CSS from my JavaScript. So we're seeing, of course, the combination between HTML, CSS, and JavaScript. I'm going to set the color property to blue-ish. And then whenever the mouse leaves this div, I'm going to call makeGreen on it and change it to greenish. So I can react to the user. This just reacting to the mouse moving into an element. But there's lots and lots of powerful things you can do with this. You can react to just about anything your user is doing by listening to the user events. And again, W3 Schools, yes, I referenced that a lot in this lecture. But this has a lot of examples of what you can do with this. I already mentioned that. And in your JavaScript, you've seen console.log. I've mentioned this a few times this semester even. Whenever you do console.log, it's going into your browser console. I already showed a browser console demo, actually. If you go into the console tab of your browser console, or your dev tools, I think the whole thing is usually called, you can see all the output from your JavaScript. So if you want to do some good old print line debugging, console.log, and then check out that tab and see what was actually printed by your JavaScript. Browser extensions, I have a lecture on this later, but just very briefly, it's JavaScript that's going to run whenever a page loads that automates running JavaScript. And your browser extension